podcast. This is Mr. White,
And Mr. Sadler.
and today we're going to talk about riding an elevator, which is just a really boring roller coaster.
Right.
The elevator here at school is not great because it's very safe. It's only got one floor to go up and down, so you have a hard time experiencing the sensations of heavy and light. And of course, this is just like riding a roller coaster.
Correct.
So let's talk about the roller coaster, then let's go to the elevator, and then we'll come back to the roller coaster.
Okay.
So I come down the first hill, I hit the bottom, I come up to a second hill. That's a pretty standard roller coaster ride.
Right.
So, Mr. Sadler, have you ridden a roller coaster in your life?
Of course.
Not recently?
No, thank goodness.
No, not recently. When do you feel heavy on a roller coaster ride?
Okay, so you feel heavy at the bottom.
So you feel heavy here.
Correct.
Have you ever done an experiment to verify this heavy sensation?
I guess not really.
No.
You could probably hold a spring scale or hold an accelerometer and see it. I have seen, the vests at Great America
Ooh,
that they actually.
the nerd vest,
Right.
With packs your calculator and your accelerometer in a waterproof pouch.
Right.
They think we're making this up. So then where would you feel light?
At the top of the hill, as a matter of fact, you could actually experience it would be negative, right, where you actually come out of your seat.
Yeah, you have the lap bar to keep you from leaving the roller coaster cart.
It would be drastic, but theoretically you could be lifted out of your seat.
Yeah. And so when we talk about feeling heavy or light, we're generally talking about this stomach sensation that you get. Have you ever felt heavy at the top of a hill?
No.
And have you ever felt light at the bottom of one?
No.
So these are just everyday experiences that you could have on a roller coaster, or as it turns out, in an elevator.
Right.
So we're going to get a little math heavy on the talk today, but we're going to talk about riding on an elevator, and we're going to get very specific about the situations.
Right. So we were just talking in qualitative terms, and we're going to talk a little bit more quantitative later, right?
Yeah. So there you are, riding in an elevator. And let's say that we are at the top,
Okay.
and we are going
Down. Okay. So in an extreme elevator, if you cut the rope, you're at the top going down,
Correct.
and you would feel light.
So you're starting, and so your prediction is that we'd feel light.
Right.
Okay.
Because if I cut the rope going down, I'd be going down, and I would basically feel light.
So there's some weight force down,
Correct.
and we call it the normal force going up.
Correct.
This happens to be the scale reading, by the way. That when you step on a scale, you're actually reading the normal force via the third law.
All right.
Okay? And so if you are going down, we'll do this in a different color. Could you tell me what direction the acceleration is in?
It's in negative, right?
Yeah. So acceleration is down, and therefore you said negative. So we reach way back to Newton's laws. Because we are accelerating, we say that the force, sum of the forces up and down equal mass times acceleration.
Correct.
But in this particular case, because we're accelerating down, it would be negative.
Right.
So I got normal going up minus the weight equals negative ma. And if I wanted to know the scale reading, or the normal force, I would add Fg to both sides. And what do you notice? That the normal force is equal to your weight, which makes sense,
Right.
but minus your mass times acceleration. So something minus your weight, what do you feel?
Light.
Light. That's
Absolutely.
amazing. What about if we repeat this? Actually, I'm going to cheat. What if we repeat this and I just erase some of this good stuff here? Okay. Beautiful. Okay. Instead of starting at the top, let's say I'm stopping at the top.
Okay, so I'm going from the from lower floor up, and I'm going to stop.
Okay, so what direction is the acceleration? You're on your way up, but you're slowing down. So remember this diagram we did? We have a positive V, but we're slowing down. So the acceleration must also be negative.
Correct.
Okay, so get my red arrow out again.
It's going to be the same, right? I'm going to feel light again.
Yeah, that's the prediction. The prediction is light because we just did this math problem.
And you can really do this. You know, it makes sense, right? I have an orange in my hand, and I lift it from the floor up quickly, and the orange comes out of my hand. It feels light.
Right. It sounds like actually our
Same thing.
investigation.
Same thing.
Yeah. And so there's the math. There's the math to prove it. So at the top of an elevator, just like at the top of a roller coaster ride, you always feel
Light.
light. There's no exception to that rule. If you doubt it, I recommend that you go to a place with a few more floors so that the elevator gets up to a higher speed. The hospital is a good place if you're at the
Thinking
hospital.
about Willis Tower or something
Well,
like this, but they probably go slow enough. The
No.
acceleration is probably slow enough.
Those skyscraper elevators, they
I
go.
wonder if you could see that clearly on a.
A hotel elevator would be a good choice. I'm trying to think of things locally here that would work. But the high school is not a great place. So then we've done the top. So my next question then, well, what about if you start at the bottom? Or
Okay.
what if you're at the bottom?
So at the bottom going up.
Okay, so we want to say we start at the bottom.
Okay.
We're going up. So the acceleration has to be
Positive.
positive. So bottom starting, and the acceleration has to be positive. So what's your prediction?
I'm going to be heavy. If you think about it again, if I'm standing on an elevator and something else is pulling me up, the motor of the elevator, so I've got the weight of me on the scale
Plus
and I've got that acceleration
your
upward.
acceleration. So when you accelerate an object, you're generating a force.
This is really, this is a space shuttle too, right? I mean, this is a rocket. It's the up force plus the force.
Right.
That's why I feel so heavy in a space.
And so what
space
you
capsule.
could do, if you could actually measure this, is you could analyze the Fn, and you could say, oh, well, it's my weight plus this ma. So it's all based on how big is the acceleration to change into how many g's of force are you going to take, which we'll be talking about in another podcast. So I'm not going to erase all this. I'm going to change one word. Okay, so let me go ahead and get my eraser out.
And now instead of bottom going up, I'm at the bottom stopping. So I went from a top floor and I'm coming down, 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 and suddenly I stop.
Right, so I have to change two words.
Okay, so
In order to stop me from crashing in the
Right.
elevator, the acceleration has to be
Up.
positive or up.
right. So this is hard for people to understand sometimes that the acceleration is up when I'm going down, but it's just a braking thing again.
Right. Remember, we had this velocity column, this acceleration column, and this motion column. So what we just described, and let's relate this to our elevator. So if we had a positive velocity with a negative acceleration, yes, we were slowing down.
Right.
But we would be at the top going up or stopping.
Right.
Okay? If I had a positive velocity with a positive acceleration, that would be at the bottom going up,
Right.
and I'd be speeding up.
Right.
So relating this to our elevator. If I was negative, negative, I would be going down and getting faster, so I'd be at the top, heading down,
Speeding up.
speeding up. And if I was negative, positive, I would be at the bottom, going down, so I'd be slowing down. Done.
Right.
So this isn't news. We go back to our roller coaster. You said that you never feel light at the bottom,
Right.
and you never feel heavy at the top,
Right.
and our elevator proves it.
Right.
Really, really fascinating stuff that we could take something as boring as elevator music and turn it into roller coaster physics.
Right. Same thing. Really, it's just less forces that you feel.
The book does some problems as far as with some actual numbers, so you might want to take a look at those in the green pages. And when we do this, Your weight is FG. What the scale is reading is called your apparent weight. Meaning it's not actually your weight, it's just what the scale says it is at that moment. So, yes, scales do lie.
Right.
Signing off, this is Mr. White.
And Mr. Sedler.